हाँ कर दिया. Line integral looks like this, right? Where what we discussed was that this object is a vector function and this object is the line element. This is the starting point. This is the end point. Right? So this is the anatomy of a line integral. And we discussed in detail what a vector function is and what a line element is. Okay, so I hope there is no confusion there. Just to remind you, a vector function is nothing but a function of the coordinates I cap plus some other function of the coordinates j cap plus some other function of the coordinates k cap, and the line element is always dx I cap plus dy j cap plus dz. Okay, so today we are going to discuss how to work out the line integral. Okay, and this is going to be very different from how to work out a normal integral. Okay, there may be similarities, but mostly it is going to be different. Okay, so let's start with this. How to solve a line integral. So the way to solve this line integral is first we must know what is required. So what do I mean by this? Let's say that we are talking about normal integration. Right? So if we are talking about normal integration, then what are the things that you require so that you can carry out normal integration? So what you need is the function. So I'll say integrate x square. We will do integral x square dx. And you need the lower and the upper limits. And that's it. You don't need anything else. I mean, now you are in a position to give me an answer. So what are the requirements here? First, let me write that down. So prerequisites of solving a line integral. Number one is you must know the vector function f. Okay, तो obviously ये तो जिस फंक्शन को इंटीग्रेट करना है वो तो आपको मालूम ही होना चाहिए. It is not going to be like this. This is not going to be. This is not going to be the vector function. It is not going to be this complicated. It is going to be something like mg minus j cap. It is going to be extremely easy, something very easy. F is equal to, I don't know, some constant. that is also a vector function. Some constant I cap, some constant j cap. So you need to know what that vector function is, right? बड़े बड़े मैं words use कर रहा हूँ, vector function और ये वो, मतलब बहुत छोटा है, right? It will be a constant I cap, constant j cap. बहुत ज़्यादा हुआ तो it will be something like, I don't know, something like x I cap. और बहुत ज़्यादा हुआ, उससे ज़्यादा हुआ, we will discuss cases like this. Y I cap plus x j cap, right? This is the limit of complication of a vector function that you are going to get. So we need to know कि हम integrate किसको कर रहे हैं, right? Vector function की जानकारी हमको जरूरी है. Number 2 is we need to know the upper and lower limits. Now again, terminology is the same, but meaning is slightly different. I'm going to show you that after the solution, you are not going to substitute these values into the answer, right? At least with the method that we are discussing. We will discuss another method. I think थोड़ा बहुत हमने last class में किया था. We will discuss another method where the integration will involve substitution of the Ri and Rf after you have carried out the integration, right? But that will come later. The weird part here, okay, the really weird part here is that this is not enough. Now, there is another prerequisite, right? There is another requirement. There is something else you must know for solving this. Line integral. एक मिनट रुको जरा मैं इसी सेट कर लूँ. हाँ, okay. So there is another requirement of solving the line integral, which is extremely weird. Okay, and it has no analogy, it has no precedence in the integration that we have already learned, right? That's why I said please don't have any presupposition. Okay, abhi somebody was asking me why don't we substitute, why can't we substitute? Because of the fact that this is something which is completely different. Okay, now you can't say कि मैं स्पेन में जाऊंगा और मैं तमिल में बात करूंगा. क्यों नहीं बात करते लोग? तमिल में क्यों नहीं बात करते हैं भाई? स्पेन में नहीं करते हैं, वहां पे लैंग्वेज दूसरा है, राइट? लेकिन मैं तो जाके वहां पे तो मैं उसी में बात करूंगा. तो that does not make sense. So here the method of integration is completely different as compared to the previous method of integration, and therefore whatever we followed over there may or may not work here. If it does, I will show you. If it does not, okay. Terms थोड़े से similar हो सकते हैं ना विश्वजीत. I cannot be inventing terms every time. ऐसा नहीं कर सकते ना. आपको अगर दिक्कत है तो आप दूसरा टर्म आप बोल दो कि नहीं मैं तो बोलूंगा ही नहीं, मैं तो कुछ और ही बोलूंगा. But then don't you think that will create even more confusion? अब विश्वजीत बोल रहे हैं कि नहीं मैं तो ये लोअर अपर लिमिट बोलूंगा ही नहीं, मैं तो इसको I don't know पेरिजी अपोजी बोलूंगा, but that does not make sense. So the third thing that we require, the weird thing, is the path followed from the initial position to the lower to the final position. So let me tell you what I mean by this. So here we have a three-dimensional coordinate axis, and here we have some position vector Ri, and here we have some position vector Rf. Right. So what I'm saying is that apart from having a knowledge of Ri and Rf, you must also have, or we must also have, a knowledge of the path taken to calculate the value of this integral. Very, very weird. This means that if the vector function is same and if the limits are same, still you may get an infinite amount of answers. Everybody doing this integral will get a different answer despite the fact that the function is same and the limits are same, because the integral value depends not only on the function, not only on the initial and final points, but it also depends on the path which the particle has taken, or which uh, which has been followed. Now you may ask, of course, ये path कहाँ से आ गया बीच में? And the answer is that since the line element is an infinitesimally small displacement vector, right? The line element is dx I cap plus dy j cap plus dz k cap, which is a step taken in space, or more accurately, it is a combination of three steps taken in space. One step dx I cap along the positive x-axis, or let me just say along the x-axis. Second step dy j cap along the y-axis, and the third step dz k cap along the z-axis. So you have come from some starting point to some final point. You have taken a minuscule, a very minute step in space, right? And you may choose the direction of this step. So if you want to go from Ri, if you want to go from the point which is at the tip of the arrow Ri to the point which is at the tip of the arrow Rf, then there are an infinite number of paths that you may take. And it is my contention, it is my uh, I'm laying down this fact that the value of the line integral will depend not only on the vector function which is to be integrated, not only on the lower and upper limits, which are nothing but the starting and the final point, but it will also depend on the paths taken by the I don't want to say particle or object, but path taken. That's it. So, with these three prerequisites, with these three pieces of information given to us, we can talk about how to solve a line integral. Yeah? So, I'm going to the next slide where I will lay down, where I will show you the steps of solving a line integral. So I'll just redraw the diagram. We have the xy axis. We have the position vector Ri. We have the position vector Rf. and we have the paths. So step 1 in finding the value of the line integral is to divide the given paths or the known path into line elements. This is the first step. In fact, it's just like calculus, right? Normal calculus may be what you do to find the integration. If you remember, integration is area under the graph. So you divide the graph into infinitesimal strips. So in the same way, in an analogous way, we are taking the path and we are dividing the path into, because it is curved and we only want to deal with straight lines, we are dividing the path into line elements or small displacements, right? And these are infinitesimally small vectors so that they fit very exactly on the curve. After dividing the path into line elements, then we can do the step 2, and that is draw the f vector for all the line elements. इसका क्या मतलब हुआ भाई? इसका मतलब हुआ कि जब मैं इस पोजीशन पे खड़ा हूं, राइट, आई एम स्टैंडिंग हियर, बिकॉज रिमेंबर एक्स वाई जेड की बात हो रही है, दैट मीन्स कोऑर्डिनेट एक्सिस की बात हो रही है, दैट मीन्स ए पॉइंट इन स्पेस की बात हो रही है. तो जब मैं इस पॉइंट इन स्पेस पे खड़ा हूं और मेरे को ये एफ की वैल्यू बताई गई है, मेरे को ये एक्स वाई जेड का फंक्शन, ये एक्स वाई जेड का फंक्शन, ये एक्स वाई जेड का फंक्शन मुझे बताया गया है, तो आर आई के हेड पे जब मैं खड़ा हूं तो वहां पे कुछ ना कुछ एक्स वाई जेड कोऑर्डिनेट्स हैं. ओके, so when I stand, okay, when I stand at that point, I know what my coordinates are, and I can feed those coordinates into these expressions, and I will end up with a vector quantity, something I cap, something j cap, something k cap. And when I end up with such a vector quantity, then what I can do is I can draw that vector quantity here. Right? So let me call this F1. Okay, right? And now I take one step and I move to this point. It is an infinitesimally small step, but a step nevertheless. And when I am at this new point, then the coordinates of this new point are different. And when I feed in the values of coordinates of the new point to that vector function, I get a different vector. So I draw that vector here. Let me call this F2. Okay, and similarly, when I take the next step, I'm here, and the force will be something different, right? And ultimately, I will come here, the force will be, I don't know, Fn. And ultimately, I'll come here, and the force will be something like Fm, something, where n and m are some numbers. Actually, m और n लिखना चाहिए because पहले वो आ रहा है, but ठीक है. So I have to draw the f vector for all the line elements, and then the step 3, then the third step is to find the angle between all f and dl vectors. Okay, अब इसका क्या मतलब हुआ? Right now, I'm sure by now you must be thinking, यार ये तो बड़ा गड़बड़ चीज है. ये एंगल निकालना पड़ेगा, फिर ये एंगल निकालना पड़ेगा, फिर ये एंगल निकालना पड़ेगा, फिर ये एंगल निकालना पड़ेगा। कितने एंगल निकालते रहेंगे भाई हम लोग बैठ के। So I am telling you the method of solution, right? Now, when we actually go and solve this, then what kind of complications will come and how they will be ironed out, that also I will tell you. Rest assured कि आपको इनफाइनाइट एरोज नहीं बनानी होंगी डीएल की, और इनफाइनाइट एरोज देयरफॉर फोर्स की नहीं बनानी होंगी, बट टेक्निकली दैट इज व्हाट शुड हैपन. After you have found the angle between all forces and all f, sorry बार बार मैं forces बोल रहा हूँ, all f and dl vectors, now I can tell you how to solve this line integral. Yeah, so I'll just write it here. Step 4. Integral of f dot dl is equal to the summation of the dot product of these f vectors and dl vectors. F2 dot dl2 plus F3 dot dl3, and so on and so on and so on. Right? So this vector dl1, this vector dl2, so on and so on. So integration का sign, remember, is an elongated S. It represents the sum. In the case of normal integration, it represents the sum of something else. In this case, the line integral represents the sum of dot products. Okay? And the dot products are those which are between the force vector and the dl vector. Dl vector being the line element which has been arranged along the path that has been followed, and the f vector is the value, the literal value of the f vector at these different points in space where these dls have been made. Okay? So when you start finding the dot product of all the f and dl and you add them up, you get the line integral ka value. Let's expand this. We know that this is equal to, we know that this is equal to f1 dl1 cosine theta 1, f2 dl2 cosine theta 2, f3 dl3 cosine theta 3, and so on. We know this. We know how to carry out a dot product, right? And we have done that. And this is it. This is the definition. This is how you carry out a line integral. And you must ask, limits kahan hai? Well, the limits are here. They are inbuilt. So this guy is at the starting point. Okay, and this guy, ये जो end में आएगा, this is at the end point. Okay, so you see, you don't need to substitute the values of Ri and Rf. This is it. This is how you carry out a line integral. Of course, I will never ever subject you to a condition or to a situation where you are in a very weird position where you have to find out the infinite sum of something, right? So you can be rest assured that something else will happen which will make this infinite sum extremely easy to calculate. And that is what I want to show you now. So please take a screenshot of the screen, or please write this down in your copies. That is better, okay? Because I want you to really learn this. So, नहीं, सोनल आप लिमिट्स कहाँ पे डालेंगे? आप मेरे को बताइए ना. You tell me where do you want to put in the limits? Why is there requirement for you to put in the limits? Where will you put in the limits? ये आंसर है, ये इसका इंटीग्रल का वैल्यू है ये. अब आप इसमें लिमिट्स कहाँ डालो? एफ में डाल दोगे आप. आप बोलोगे नहीं मैं तो यहाँ फोर्स नहीं, मैं तो यहाँ पे आर आई लिखेंगे, या डीएल में आप डाल दो, या कॉस थीटा में आप डाल दो. राइट, उसकी रिक्वायरमेंट ही नहीं है. लेकिन लिमिट्स यहाँ पे एग्जिस्ट कर रहे हैं. लिमिट्स क्यों एग्जिस्ट कर रहे हैं? क्योंकि ये जो हमने डॉट प्रोडक्ट कैरी आउट किया है, ये डॉट प्रोडक्ट यहाँ पे है स्टार्टिंग पॉइंट पे, और जो आखिरी में डॉट प्रोडक्ट हम कैरी आउट करेंगे वो डॉट प्रोडक्ट यहाँ पे होएगा. राइट, तो हम लिमिट्स तो फॉलो कर रहे हैं, हम बता रहे हैं इसको कि हाँ भाई देखो, हमने जो पहला डॉट प्रोडक्ट कैरी आउट किया वो आर आई के हेड पे किया, लास्ट डॉट प्रोडक्ट जो कैरी आउट किया वो आर एफ के हेड पे किया. लेकिन बीच में जितने डॉट प्रोडक्ट्स हैं, they will depend on what? They will depend on the path that has been taken from the initial point to the final. Okay? So this must be absolutely clear to everyone that the line integral is nothing but a summation of dot products. Dot products of what? Dot products of the two vectors f and dl. What are the values of f and dl? Well, as you go from Ri to Rf along the given path, for every infinitesimally small step you take, you have to calculate the value of f, and you have to calculate the value of dl for every step, and you have to carry out a dot product between these two vectors. And when you add these two, when you add these infinite number of dot products, you will get the value of the line integral. Okay, so please do not carry the burden in your mind कि ये कैसे हुआ. नहीं नहीं नहीं, ये डेफिनेशन है, ये ऐसे ही इंटीग्रेशन होता है. राइट, दिस इज द वे टू इंटीग्रेट. ये कहां से आया? किस किस गधे के दिमाग में ये बात आई भाई? This is a legitimate question. Whatever maths we are doing, which is higher maths, calculus हो गया, या ये वेक्टर इंटीग्रेशन हो गया, और जो आगे हम करेंगे, ये सारी मैथ्स रेट्रोस्पेक्टिव. न्यूटन had a need to invent calculus because of the fact that he wanted to calculate the rate of change of things. He knew that something is there, something is lurking in the rate of change of things. He knew, okay, or he had this intellectual leap that from the data of the planets which are going around the sun, or whatever apple falling on his head, he knew that something is lurking in the rate of change of things. But at that time, there was no maths which could describe the rate of change of things. So he invented calculus so he could deal with rate of change of things, right? Similarly, this maths has been invented so that we can explain certain physical phenomena. तो वो फिजिकल फिनोमिना क्या है वो हमें ऑलरेडी मालूम है, वो लोगों को दिखाई दे रहा था, वो लोगों ने बहुत अच्छे से ऑब्जर्व किया और फिर उन्होंने बोला कि हम अगर इस तरीके से इंटीग्रेशन डिफाइन करेंगे तो हमें कुछ मीनिंगफुल क्वांटिटी मिलेगी, ठीक है ना। सो प्लीज डोंट हैव ए प्री सपोजिशन इन योर हेड कि नहीं ये तो ऐसे होना चाहिए, नहीं, ये बिल्कुल ही नई चीज है और आपको इसको ग्रास्प करने के लिए वाकई में एफर्ट लगाना पड़ेगा। दैट्स व्हाई आई एम सेइंग राइट दिस डाउन, okay, you should be writing this down in your copy. I will wait until you finish writing. After you've written, please type yes so that I can move ahead. Yeah. So this is the definition, okay, of the line integral. Now, if you are a part of screenshot ले लेना यार, अब इतना नॉवल थोड़े लिखने को बोला है मैंने. Now, okay, now you may be very lucky. Okay, you may be very lucky, and your luck will stem from the fact that if theta 1 is equal to theta 2 is equal to theta 3 is equal to, all angles are equal. Okay, so you take infinite number of steps to go from Ri to Rf, and for each step you are calculating the value of the vector f by putting in the coordinates in the vector function. And whenever you find the value of f, whenever you draw the vector f along the path that you are walking, along the path that you are moving, you find that the angle between the vector f and the vector dl, which is the line element or the displacement that you are doing, that you are making, the angle between these two remains constant. आप कोई भी dl आप ले लो और उसमें आप f आपने बनाया f वेक्टर उस dl के लिए, उनके बीच का एंगल हमेशा कांस्टेंट रह रहा है. इस केस में इंटीग्रल f डॉट dl will become f1 dl1 cos theta plus f2 dl2 cos theta and so on. And here I can take cos theta common. When I take cos theta common, then I'm left with another sum inside the brackets. And this sum I can write as integral f dl. Please notice there are no vector signs now, and it turns out that this object is a normal integral. Normal calculus wala ye integral. Right? So if you are extremely lucky, you may end up with this situation. If further, right, आपका लक चेंज नहीं हो रहा है, आपका लक बहुत अच्छा है, एक लकी स्ट्रोक हुआ और ये दूसरा, if further magnitude of f is constant, that means that ये जो थीटा, तो थीटा 0 है, पार तो cos 0 कितना होता है, cos 0 कितना होता है, तो फिर cos 0 1 हो जाएगा, खत्म. So if further, that means ki not only have you found that for all the line elements, the angle between the vector f and the line element is constant. Okay, हाँ यहाँ पे लिमिट्स नॉर्मल इंटीग्रल वाले होंगे. हाँ, apart from this, you also find that the magnitude of the vector f always remains constant. Okay? Then integral f dot dl will become, cos थीटा तो हमने कॉमन लिया ही हुआ है पहले से, यहाँ पे f भी कॉमन आ जाएगा. So you will get f cos theta integral dl. Okay, now what do you think is integral dl? What do you think is integral dl? Let me put this slide. Integral dl, remember अब वो वेक्टर नहीं है. Okay? It is not a vector. हाँ सही सही. Integral dl is not a vector. Okay? So if it is not a vector, then it must be the magnitude of the infinite displacement. Right? It must be the magnitude of the little green arrows that I have drawn. And if it is the magnitude of the little green arrows that I have drawn, then integral dl must be what? It must be the sum of the lengths of the little green arrows. Therefore, integral dl must be what? Integral dl must be the path length. Okay, right? And if further, okay, if further, so this is a hat trick. You must be so lucky that you are scoring a hat trick of good luck. पहला, आपको सारे एंगल इक्वल मिले. दूसरा, मैग्नीट्यूड ऑफ सारे f आपको कांस्टेंट मिले. तीसरा, if further the path is a straight line, क्या होगा? I hope some of you, when I asked what integral dl will be, I hope some of you did not have the temptation to say that integral dl will be the displacement. No, it will not be the displacement. If it was the integral of vector dl, yeah, then it may have been the displacement. But it is not the sum of vector dl, it is the sum of magnitude of dl. Therefore, it is the path length. But when you are traveling on a straight line, then what happens? When you are traveling on a straight line, then what happens? When you are traveling along a straight line, then what happens? The distance traveled and the magnitude of displacement are, याद है ये हमने काइनेमेटिक्स में किया था. अगर हम बिल्कुल सीधी लाइन पे चले जा रहे हैं तो डिस्प्लेसमेंट और डिस्टेंस ट्रैवल्ड सेम होते हैं. So in this very rare case, when you have these three conditions, when you have these three conditions which are met, right, then integral f dot dl becomes f cos theta into displacement. Okay, so this is how you carry out the line integral. Okay, and I'm going to change the slide, so please write this down first. पार्थ जल्दी लिखना. हाँ, displacement, yes. हो गया? So basically you have to realize अगर ये एंगल्स इक्वल हैं तो ये नॉर्मल इंटीग्रल में कन्वर्ट हो जाता है, और ऊपर से अगर मैग्नीट्यूड ऑफ एफ कांस्टेंट है तो वो भी इंटीग्रेशन के बाहर आ जाता है। और ट्राइफेक्टा, तीन चीज अगर एक साथ हो जाए, थर्ड बीइंग दैट द पाथ इज अ स्ट्रेट लाइन, then you get integral dl as displacement. So why have we been learning all these things? The purpose is that in physics we define a quantity called work. Okay, now this work has got nothing to do with our daily life. The term that we use in daily life, उससे कोई लेना देना नहीं. Work is a pure mathematical quantity. Work done, by a force is defined as line integral of the force Ri to Rf. Work done by force now you should be remembering the this expression. क्लास 9th और 10th में आपको वर्क डन पढ़ाया गया. आपके टीचर ने बोला कि हम आपको आज वर्क डन पढ़ाएंगे, वर्क की डेफिनेशन बताएंगे. Your teacher told you that the definition of work, I hope the teacher told you that the definition of work is अलग अलग लोग अलग अलग बातें बोलते हैं. The most common I have found is F force into displacement into cos theta. विश्वजीत को cos theta नहीं बताया गया, फॉर एग्जाम्पल. केवल force into displacement बताया गया, right? But some people, they in class 10 they are introduced to हाँ, कुछ लोगों को हाँ बिल्कुल, yeah, some people were told force into displacement, some people were told force into displacement into cos theta. In either case, this definition of work that you were told is absolutely correct with the level of maths that you knew at that time. Okay? आपके टीचर से ज्यादा आपको बता ही नहीं सकते थे, आपको समझ में ही नहीं आता, आपको लगता कि ये कोई एलियन लैंग्वेज ये बोल रहा है टीचर, राइट? सो नाउ I present to you, I put in front of you actual definition of work, okay, with full mathematical complexity. This is the definition of work done by a force. And if you are lucky 3 times, if it so happens that when you go from the initial position to the final position, so basically we can discuss the physical implications of this. तो एक ऑब्जेक्ट के ऊपर फोर्स लग रही है
मल्टीपल फोर्सेस भी लग सकती हैं, मल्टीपल फोर्सेस लग भी रही हैं तो मुझे कोई मतलब नहीं है, मैं केवल एक फोर्स की बात कर रहा हूं। ये ऑब्जेक्ट उस फोर्स के इन्फ्लुएंस में या किसी और फोर्स के इन्फ्लुएंस में, डज नॉट मैटर, ये ऑब्जेक्ट आर आई से आर एफ ट्रेवल करता है, ठीक है ना। एक पॉइंट पार्टिकल है, वो आर आई से आर एफ ट्रेवल कर रहा है, उसको कौन मूव कर रहा है, वो क्यों ऐसा पाथ फॉलो कर रहा है, उससे मुझे कोई मतलब नहीं। मेरे को ये मालूम है कि वो ऐसे मूव कर रहा है, तो वो पॉइंट पार्टिकल ने जो पाथ फॉलो किया, मैं उस पाथ को छोटे छोटे डिस्प्लेसमेंट्स में डिवाइड कर दूंगा और हर डिस्प्लेसमेंट के लिए मैं निकालूंगा कि फोर्स की वैल्यू क्या है। कौन से फोर्स की वैल्यू? जिस फोर्स की वजह से मुझे वर्क डन निकालना है। और भी फोर्सेस उस पर एक्ट कर रही हो सकती हैं, लेकिन उससे मुझे कोई मतलब नहीं रहेगा। मैं केवल उस फोर्स की वैल्यू वहां पे वर्कआउट करूंगा जिसके लिए मुझे वर्क डन निकालना है। जब मैं सारे स्टेप्स, सारे डिस्प्लेसमेंट्स के लिए ये फोर्स वेक्टर बना दूंगा, तब मैं एक सीरीज ऑफ डॉट प्रोडक्ट्स कैरी आउट करूंगा, एंड दिस डॉट प्रोडक्ट विल बी बिटवीन the step that I have taken, the displacement that I have done, or the displacement of the particle, and the force on the particle, right? Sir, we defined the f cos theta displacement for work done, but are the steps we did valid for other vectors too? ये मुझे नहीं समझ में आया। Sir, f into s cos theta is used to find the displacement vector along the force vector. ना, ये भी मुझे नहीं समझ में आया। जो मैं बोल रहा हूँ उसको समझो, try to understand. I will say it once again. Okay, try to understand. I'll say it once again. Everything I'll repeat. I have a point particle in space, maybe your pen. Okay, let's take your pen as an example. आपका पेन टेबल पे रखा है, आई होप। आपने पेन को उठाया और आपने जो है उसको कोई पाथ फॉलो कराया और आपने वापस किसी और पॉइंट पे टेबल पे रख दिया, या बुक शेल्फ पे रख दिया, या बुक के ऊपर रख दिया। Now your pen has an initial point and a final point and a path which it has followed. Everybody agrees with this? आपका पेन टेबल पे रखा है, आपने पेन को टेबल से उठाया और आपने उस पेन को टेबल पे कहीं और रख दिया या कहीं और ही रख दिया, और आप अपने हाथ को गोल घुमा रहे हो या जो भी, whatever way that you are taking the pen from point A to point B, the pen has an initial point, the pen has a final point, and the pen has followed a path to go from this initial point to this final point. ये आया समझ में सबको जो मैंने बोला अभी? पेन की कहानी समझ में आई? अब ये पेन के ऊपर क्या फोर्सेस लगी हैं? पेन के ऊपर क्या फोर्सेस लगी हैं? भाई, पेन के ऊपर ग्रेविटी लग रही है और पेन के ऊपर एक एक्सटर्नल फोर्स लग रही है जो आपके हाथ ने उसके ऊपर लगाया हुआ है। राइट? So you have taken your pen from a point A to a point B in your room and you have followed a certain path. The pen has followed a certain path, and in the duration of this path, the pen was under the influence of at least two distinct forces. One is mg due to the earth, and the other is the external agent wala force which has been applied by your hand. Now I can ask the question, okay, I can ask the question, what is the work done by mg in this case on the pen? Okay? और अभी मैं न्यूमेरिकली आपको वर्कआउट करके दिखा रहा हूँ, एक मिनट. So now I can ask the question, what is the work done by mg on the pen? To do that, अब ये क्वेश्चन मैं पूछ ही क्यों रहा हूँ वो बात अलग है, वो that we'll explain later. बट अगर ये क्वेश्चन पूछ लिया गया कि what is the work done by mg on the pen, then what you must do is that you must divide the path into small elements. तो बेसिकली आप अब वापस से पेन को पॉइंट ए से पॉइंट बी पे ले जाओगे और आप इस पेन को पॉइंट ए से पॉइंट बी सेम पाथ पे ले जाओगे, राइट? लेकिन अब आप इसको वीडियो रिकॉर्ड करके, आई डोंट नो, वीडियो रिकॉर्ड करके इसको बिल्कुल स्लो कर दो. When you look at the recording and your hand is moving, right? You have slowed down the speed. You have slowed down the speed of playback. स्लो मोशन में देख रहे हैं. स्लो मोशन में हमें क्या दिखाई देगा? The hand will move in steps. तो ये जो स्टेप में हाथ मूव किया, राइट, ये हमने एक इनफाइनाइटिसली स्मॉल वहां पे डिस्प्लेसमेंट वेक्टर बना दिया कि पेन इतने से डिस्प्लेस हुआ बिटवीन टाइम 0.01 सेकेंड टू 0.02 सेकेंड. उस ड्यूरेशन में जो इसका डिस्प्लेसमेंट हुआ पेन का, वो एरो हमने बना दिया और हमने mg का एरो बना दिया वहां. अब हमने mg और ये जो छोटी सी एरो हमने बनाई है, इसका हमने डॉट प्रोडक्ट ले लिया. Taking the dot product is very easy, right? Remember, it is nothing but AB cos theta. इसी तरीके से ये पेन जो इनिशियल पॉइंट से फाइनल पॉइंट, जो भी पाथ आपने उसको दिया, जो भी पाथ से गया, जब मैंने उस पाथ को डिवाइड करके हर एक पॉइंट पे मैंने ये कैलकुलेट किया डॉट प्रोडक्ट बिटवीन mg एंड dl, और जब मैंने इन डॉट प्रोडक्ट्स को ऐड किया पूरा, that will give me the work done by the earth on the pen. Okay, that will give me the work done by the earth on the pen. Now this sounds very complicated. Okay, this sounds very very complicated. यार ये चल क्या रहा है, कैसे करेंगे ये? But it is like driving a car, right? I hope all of you at some point of time have driven a car. वो बच्चों वाली थी या बड़ी वाली थी, it does not matter. The point is that the car has a very complicated internal mechanism which you do not understand, which in all probability you do not understand. However, driving the car itself is very easy. The steering wheel है, उससे आप लेफ्ट राइट कर सकते हो. एक्सेलरेटर और ब्रेक है, उससे आप गाड़ी को आगे बढ़ा सकते हो और रोक सकते हो. In the same way, this what I have written, ये जो अभी स्क्रीन पे आपको दिखाई दे रहा है, this is the mechanics of the car. Okay, this is the internal working of the car.
I will show you in the next 5 minutes. When we calculate the work done by the earth, for example, we will arrive at a result which will be extremely easy. And next time you are asked to find the work done by earth, you are going to follow that extremely easy step and not this which is there on your screen. Okay, so you know this, ये आपको मालूम है कि जब मैं वर्क डन बाय अर्थ निकाल रहा हूं तो उसके पीछे एक कॉम्प्लिकेटेड मैकेनिज्म है. Whether you remember this complicated mechanism or not does not matter. What you should remember is the easy result that we are going to get. Okay, and I will show you. I'm changing the slide. Before I do that, just let me write here that this is a scalar quantity and the units of the scalar quantity are joules. Okay, so what I want to do now is I want to calculate the work done by Earth or gravity. Why am I doing this? Why am I doing this? Well, I told you at the start of Newton's laws of motion that there are 5 objects in the surrounding of a system which are capable of applying force on the system. These 5 objects are earth, surface, string, spring, and external agent. Sorry. If these 5 objects are capable of applying a force, then it is only these 5 objects which are capable of doing work. Okay? If these 5 objects are capable of applying force, then it is these 5 objects which are capable of doing work. So just like at the beginning of the Newton's laws of motion chapter, I told you the magnitude and direction, whether it was known, unknown, jo bhi tha. I told you the magnitude and direction of the forces generated by these 5 objects. In exactly the same way, we are going to work out the work done by these 5 objects. Okay, so first is the work done by the earth. So this is the initial point. This is the final point. And I need to choose a path. So let this be the path. Please notice that the path is arbitrary. That means that whatever result I will get here should be valid for all paths. क्योंकि मैंने तो arbitrarily कुछ भी choose कर लिया. Okay, so let's follow the steps here. What are the steps? Step number 1: divide the given path into line elements. Okay. Divide the given path into line elements. So I can do this easy. Line element. Now it should be infinitesimal technically, but I'm not going to do that. नहीं तो मैं तो ये दिन भर रात भर अगले साल तक यही करते रह जाऊंगा. So it must be such that I get a set of arrows which are straight and they are
comfortably along the given curve. So I divide the path into line elements. Okay, what is the next step? Draw the F vector for all the line elements. Okay, okay, no problems. The F vector in this case is mg, and mg is having a constant direction and magnitude. So mg, 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 mg. आई एम सॉरी अगर वो ब्लू एरोज का थोड़ा सा मैग्नीट्यूड ऊपर नीचे हो जा रहा है. आई एम सॉरी अबाउट दैट, बट यू अंडरस्टैंड व्हाट आई एम सेइंग. सारे मैंने एरोज बना दिए, सारे एमजी बना दिए. व्हाट इज द नेक्स्ट स्टेप? नेक्स्ट स्टेप इज find the angle between all f and dl vectors. Ooh, well, I don't know. So I will just say that this is theta 1, theta 2, theta 3, theta n. I don't know the angle, so I just. What is the next step? Oh, the next step, I can actually work it out. I can actually work out what the line integral will be. So let me work it out here. So work done by mg, this is what we are calculating, must be equal to integral f dot dl from the initial position to the final position. This is equal to the dot product here. Let me call this dl1, and of course this is mg, this is mg. Let me call this dl2, this is mg. Let me call this dl3, so on. So this is equal to mg dl1 cosine theta 1 plus mg dl2 cosine theta 2 dot 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 plus mg dln cosine theta n. Right? This is the value of work done by mg. However, I am not lucky. If I was lucky, then all the angles would have been same. Okay, and then I would have taken out cosine theta and whatever. लेकिन यहाँ तो ऐसा है ही नहीं, या है? What do you think? I can take, I can take out, yes, exactly, yes. I can take out mg common, yes. So if I take out mg common, I need to check whether I am left with something meaningful in the brackets or not. dl1 cosine theta 1 plus dl2 cosine theta 2 plus dln cosine theta n. Can anybody guess what is dl1 cosine theta 1? क्या है dl1 cosine theta 1? Look at the diagram. What is dl1 cosine theta 1? नहीं भाई, mg थोड़ी ना है. mg कैसे हो सकता है? dl1 cosine theta 1 is the very good Smith. Yes, it is the component of DL, DL तो एक वेक्टर है ना, DL1 cosine theta 1 is the component of DL along mg. I think this is what you meant when you wrote mg, right? So let me write this. DL1 cosine theta 1 is the component of DL along mg, and I want to draw this. I want to draw this. शदीद बेवकूफ़ी वाली बात मत करो यार, अभी क्यों कर रहा है बेवकूफ़ी वाली बात? डीएल का कंपोनेंट लेंगे तो उसके यूनिट्स क्या होंगे? डीएल का कंपोनेंट, डीएल तो मीटर में है तो उसका कंपोनेंट भी मीटर में होगा। अगर आप मेरे को बोलो कि नहीं डीएल का कंपोनेंट लेंगे तो एमजी हो जाएगा, कैसे हो जाएगा भाई एमजी? सो लेट मी ड्रॉ दिस, ओके, लेट मी ड्रॉ दिस। ये रहा DL1 cos theta 1, ये रहा DL2 cos theta 2, ये रहा DL cos theta 3, DL4 cos theta 4, DL5 cos theta 5, DL6, DL7, DL8, DL9, DL10, DLN cos theta n। अब अगर ये मैं ब्लैक एरोज को ऐड कर दूं तो मुझे क्या मिलेगा? तो ब्लैक एरो ही तो है ना ये, DL1 cos theta 1 ये ब्लैक एरो है, DL2 cos theta 2, DL2 cos theta 2 ये वाली ब्लैक एरो है, DL cos theta n ये वाली ब्लैक एरो। सारे ब्लैक एरोज को अगर मैं ऐड कर दूं तो क्या मिलेगा? नहीं, डिस्प्लेसमेंट तो नहीं मिलेगा क्योंकि डिस्प्लेसमेंट वुड बी दिस, राइट? वेक्टर ड्रॉन फ्रॉम द इनिशियल पोजीशन टू द फाइनल पोजीशन। डिस्प्लेसमेंट तो नहीं मिलेगा। अगर मैं ये सारे ब्लैक एरोज को ऐड कर दूंगा तो मुझे क्या मिलेगा? अगर मैं सारे ब्लैक एरोज को ऐड कर दूंगा तो मुझे क्या मिलेगा? देखो, स्ट्रेट लाइन मिलेगा, लेकिन वो स्ट्रेट लाइन क्या होगा? स्ट्रेट लाइन परपेंडिकुलर, ये क्या मतलब हुआ स्मिथ भाई? पाथ लेंथ नहीं भाई, पाथ लेंथ बिल्कुल नहीं। देखो मैं बना रहा हूँ। So all I'm doing is making horizontal lines all I'm doing is making horizontal lines। ये रहा DL1 cos theta 1, DL2 cos theta 2, DL3 cos theta 3, DL4, DL5, 6, 7, 8, 9. So when I add the black arrows, what do I get? When I add the black arrows, what do I get? पता नहीं तो क्या बोल रहा था। अरे डिस्प्लेसमेंट नहीं मिलेगा भाई सत्यम। डिस्प्लेसमेंट क्या होता है? क्या होता है डिस्प्लेसमेंट? Displacement is a vector drawn from the initial position to the final position. ये रहा डिस्प्लेसमेंट वेक्टर। ये काले एरो जुड़ के नीला बन जाएगा। Vertical displacement, yes, that would be a better choice of words. So this will be equal to mgh, and you have seen this before. Right? You have seen this before. You have seen this in another form. You have seen this as potential energy, but we are not discussing potential energy here, and I would not ever refer to this as potential energy. What you must remember, what you must remember, ये सबको समझ में आया कि एक काले एरो जुड़ जुड़ के लाल लाइन बन जाएंगे? इसमें तो कोई डाउट नहीं है किसी को? What you must remember is that work done by Earth is equal to plus minus mgh, okay, where m is equal to mass, g is equal to वही आपका जो कांस्टेंट होता है, h is equal to the vertical distance between initial and पार्थ। अभी मैंने बोला ना पोटेंशियल एनर्जी इसको नहीं बोलना है। I don't think you heard me. I'll say it again. This is not potential energy. Okay? This is the work done by Earth, and we have calculated the line integral. Here it is. We have calculated the line integral. This is step 4 of the line integral that we have calculated. This is step 4 of the line integral that we have calculated. उसके बाद से mg कॉमन लिया, जो क्वांटिटी ब्रैकेट में आई वो h है। So h is the vertical distance between points 1 and 2. This is very weird. This is very weird because the path does not matter. अगर मैं इसी I से इसी F किसी और पाथ से आ जाता, तब भी उस पाथ में भी dl1 cos theta 1 plus dl2 cos theta 2, and you can draw a couple of paths and you can cross check what I'm saying. You will find that dl cos theta 1 plus dl cos theta 2 and so on is indeed again equal to h. So there are some forces for which the line integral is independent of path. That means the path does not matter. Whatever path you take, work done will come out to be the same. The line integral will come out to be the same. Such forces have a special name, which we will discuss later. हाँ हाँ सही बोल रहा है। So what you need to remember, you don't need to do this. You don't need to do this ever again. This you need to remember. वर्क डन बाय अर्थ अगर हमारे सामने आज के बाद कभी भी आया ऑन ए पार्टिकल, प्लस माइनस mgh, प्लस कब होएगा माइनस कब होएगा ये भी लिख दूं मैं यहाँ पर। प्लस कब होएगा माइनस कब होएगा, plus going down minus going up. So if you find in a problem, which we are going to do in the next class, if you find in a problem that you have to calculate the work done by the earth on a particle, you don't need to carry out line integrals. In fact, after we have calculated work done by all the 5 objects, you don't need to carry out line integrals. So if in a question you get work done by the earth, if you are asked or if it is required that you calculate the work done by earth, all you have to do is look at the initial position of the particle, look at the final position of the particle, work out the vertical distance between the two positions, and just write W is equal to plus minus mgh. If you find that the final position is below the initial position, then it will be plus mgh. And if you find the final position is above the initial position, then the work done will be minus mgh. Okay. So this is the work done by the earth. Okay. Again, remember, जो ये पूरा ये जो चीज है ये, this is the mechanism of the car. Okay? We are not, although we should know, but this is something which is inside the hood. This is what we are going to be driving with. This is what is to be remembered. Okay? चलो, so next class में आगे बढ़ते हैं. अभी आपको homework work power energy में नहीं करना है because you will not be able to do any questions at the moment. After the next class, hopefully you will be able to do some questions. Okay. Any doubts? कोई भी doubt है? Please ask. This is all new stuff, right? You have to really chew this, digest this. Please try to write this in the test portion. I don't know. Please don't ask. Please write this again in your copybooks. Don't just leave it as कि notes तो screenshot तो ले लिया है. Don't do it like that. Write it. Then you will start to understand. Okay? You are not going to immediately understand everything here. But as we go on in this chapter, you will hopefully begin to understand. Please write this. Chalo, so I'll see you guys. I'll see you guys in the next class. Okay. Chalo, bye bye. Bye bye.